Okay, so we're looking at the second year Stats and Mechanics textbook, and we're doing exercise 8D, and we're on to question 8. So we've got an exam question, so that's quite good because it tells us how many marks each bit should be worth, and then it's also problem solving, so that sort of says it's not going to be an absolutely straightforward one. So what are we given? So we're given the position vector, and we're given some information about the speed. So this is actually quite similar to question 6, okay? So this idea that they give you the position vector, so you can differentiate that to find velocity. So let's get going on that. So velocity is the differential of the position vector. So the 18t minus 14 cubed is going to differentiate to 18 minus 12t squared. And ct squared, so c is just a constant that we're going to try and find. So it's the t squared that I need to look at. So if I'm differentiating t squared, I'm going to multiply by 2. I've also got that c there, and the power is going to reduce by 1. Okay, and it tells me c is a positive constant, so that might be relevant later on. Okay, and then they tell me that when t is 1.5, the speed is 15. Okay, so if I was trying to calculate the speed, I would find the velocity when t is 1.5. So let's go ahead and do that. So the velocity would be, so 18 minus 12 times 1.5 squared is minus 9. And 2 times 1.5 is 3. So, and then I've still got that c there. Okay, and then so if I was then trying to find the speed from that, I would be looking to do the magnitude. So speed, I would be using Pythagoras. So the minus 9 squared, I'm not really bothered about the minus there. And then 3c squared. Now, be super careful there, because actually what I've written is not completely correct. Okay, now you might go on and then interpret it correctly, but be really careful. So it's 3c all squared. So that's going to end up being 9c squared when I remove the brackets. And they're telling me that that should equal 15. Okay, so like I said, it's quite similar to question 6. So always what I would do for this type of question is square both sides. So I'm going to just leave that exactly as it is to avoid any confusion. I'm going to square the 15, and now just got a nice simple quadratic to solve. So in fact, I'm going to square those brackets, and I'm going to minus the 81 from the 225. I am going to divide by 9, and then this tells me why they told me that c was a positive constant, and they're saying value of c rather than values. So c is 4, they told me it was positive. Okay, and then this next bit is only worth 3 marks, so I'm expecting this to be a little bit shorter. Okay, so find the acceleration. So the acceleration is going to be the differential of velocity, and yeah, I can just about move that. I can just about see it on the same page. So I am differentiating velocity. So 18 is going to differentiate to nothing. So the minus 12t squared is going to differentiate to minus 24t. That's my I vector. I know c is 4 now. So I know now that's actually 8t. So that is just going to differentiate to 8. And they want the acceleration. They want me to work that out when t is 1.5. Okay, so no problems there. So minus 24 times 1.5 is going to be minus 36. And the j vector is not dependent upon time. And yeah, no mention of magnitude or anything. So let's just check our answers. Yeah, we got both of those.